Okay, now we're actually going to think about neural networks and machine learning together through a demonstration. So we're going to create our own neural network. And you can literally follow along. I'm going to upload the data I used to do this to create your own. So you can create your own neural network. Okay, so I have a bunch of cats and dogs that I'm going to add to my training sets. And by the way, I just got these off of Kaggle.com, a website that people who do data analytics and machine learning share data sets and code. But if you go to probably data sets, dog images, they have all kinds of stuff here. There we go. I'm gonna upload the ones that I'm using in D2L. It's gonna be a huge file, huge zip file. I'm just gonna grab like 15 or so of these and upload them, and then I'm gonna try to do about the same. I think that says 18 samples for dogs. So let me go find me some dogs. Oh boy, I forgot I have like lots of dog categories. So I'll just choose a couple from this one because I'm trying to avoid biasing the model too much to like a very specific kind of dog. Okay, so now I have a few golden retrievers, a few terriers, few hounds, I don't know what else, a couple of Basenjis. I think I got a couple of bulldogs in there. So I got 18 and 18, and now I'm going to click train model. And now I opened this up, the advanced, to show you two things, epochs and batch size. And now these aren't vocabulary you're going to have to know. But just wanted to kind of demystify what's going on because it's really not that like crazy. So a batch size is the number of training examples processed in one training round. And so a batch size of 16 is like 16 example images, which look, we only have 18 for each category. So there's a reason I'm testing it with a sparse amount of data. And then the epochs 50. Well, what is an epoch? This is one full pass through the entire training set. So imagine it's like you have a final exam based on 6 chapters of a book. And your batch size might mean, let's say your batch size is 10. Well, maybe you pull, or I should have made it a multiple of 6. Your batch size is 36, so you're going to pull 6 questions from the end of every chapter. And then once you've finished going through each chapter, so that would be like one epoch. And then you might choose 16 more and go through that whole that whole set of chapters again. That's kind of what we're doing here. But this will be interesting with a batch size at 16. Why don't I change it? Oh, I can't change it to, okay. This will be interesting. So let's click train. And this should happen pretty quickly, if my ad blocker doesn't get in the way. Okay, and now we're ready. So let's test it on some new data that it hasn't seen yet, which is, let me find it. Okay, let's go to test images. So I just have a few dogs and cats. Okay. I'm going to try this out on. So of my dogs, I wrote this one dog that kind of looks like a cat. Let's first just try this guy. I know we had some terriers in there, so let's see if it knows what a terrier is. And look at this, prediction 74% says that's a terrier. So this is that committee again. Remember that image that I show you, that diagram, and I show you that with image recognition so that you can compare that to what you're seeing here and think about how that vote is being cast. Remember, there are different layers, and some layers have committees with members that are good at identifying ears, and some are good at identifying eyes. And when they vote right, so this is going back to training, when they voted well and their vote contributed to an accurate prediction that matched the label dog, then we rewarded that part of the committee with a little bit more weight, so that now the model that we're viewing, their final judgment is a pretty firm, pretty much in the affirmative that this is a dog. All right, so let's try a Czechoslovakian wolf dog. No Czechoslovakian wolf dogs went into our training data, so let's see. And look at that. Cats, 99%. So what went wrong here? Well, there weren't any dogs that quite matched this build. I would say the German Shepherd, probably similar, but there's only one picture of him in our whole training set. And there are some kind of anatomical and texture properties that match cats. Like, look at this cat's ears versus that one, right? And so our model, this is the danger of a sparsely trained model, not enough training data. This is called underfitting the data instead of overfitting. And so what we run into is a model that sometimes the predictions are very good, like look at that one, and sometimes they could be very off. That's one way we could bias the model. Now let's try to train this up. I'm going to train this up with a lot more variety of cats and dogs and see what results we get. All right, so now I've just finished training this model on 328 samples of both cats and dogs. Nothing special about that number, just a fuller set than where we started with our 18 and saw some big gaps in the predictions we were getting. So now what I want to do is go ahead and test this. Let's see. Okay, on some test images. So let's try our dogs again. The one that gave us trouble last time, I believe, was this guy. So let's see. Still wrong. So probably we need to find more dogs of that type and add that to our set. I really thought it would work that time. Let's try this one. Okay, it got that one. I thought it might mess up on that one because it has some cat-like features. Let's see if we can test it on some cats. So I have this little orange cat, 100%. Let's see if we can test it on a hairless cat. I don't think I put any hairless cats in the training, so this will be interesting. Uh-oh. Maybe I can't use that file type. I guess not. Let's see what it thinks of a cheetah. 100% a dog. So I didn't train it on big cats. So you can see the gaps in my training again are what's hurting me. Now I'm going crazy. I am flooding the cats class with tons of cat images, but I'm not going to add any new dog images to the training data, and we're going to see what happens. Okay, so let's try it out. Let's start with this dog before. It used to be 100% accurate when we started. Now, still 100% accurate. So that's a good sign. It definitely can recognize terriers well, or at least that particular one. Let's try this terrier. Doing good there. Let's throw it a Borzoi. This is doing better than I would have expected. I thought it would call these cats simply because I have a lot more cats in there, but I'm not done yet. So, uh-oh. Well, there you have it. Um, machine learning surprises me too. So even though we don't have a huge set of dogs in here, it's doing quite well. Let me try to find something. I don't remember these going into the training. Yeah, now let's see if it can still identify cats. So what I was hoping to demonstrate with this example is how when we overload a class with far more data than another one, that it tends to always predict that class over the other one, or at least most of the time. What I've shown is actually that it seems to still be getting most of the dogs right. And as I would expect, it's really good at recognizing cats. Now let's try something totally different. Let's try people. Cat. Dog. Why? No clue. Maybe something to do with the hair. Point is, when we don't put that in our data, you don't know what you're going to get. Also, some of these training images featured people in the images. So if there were, for example, more people that looked like the first person that I tested on in the cats class, and more people that looked like the second person in the dogs class, that could be why it's voting the way it is because it's associating, it doesn't really know the literal difference between a cat or a dog. It only knows the data that it's been trained on. And so what I hope this exemplifies at this point is that if we carefully curate the data that we put into it, how much of each type of class, and give good variety, so different angle, different lighting, etc., just different features, then we're going to get better results out of this. But that is also easy to bias this by leaving gaps in our training. So what we've just demonstrated is actually that neural network that I showed you. Oops, trying to pull it up here. So we've actually created one of these, and it's predicting, what we're looking at, right? Now, the training process we use to do that is literally exactly what we talked about on the, I think I went too far, but on the machine learning slide. Yeah, this one. So it's literally this 3-step process. That's what we just walked through in order to create that model. So now what you can do, where's my model? What you can do is, if you would like to create one of these on your own, I had a student that literally made a big dog, small dog classifier, and you could go and create gray cat, orange cat, black cat, whatever classifier. All kinds of things you can do with that data set that I'm going to share. And then you can click export model, and you can actually download that and share it with me. Thought there was a way. Let's see. Download project as file. I think that's the easiest way. Download that as a file and share it if you like. You share it with the class.